So this next part of our section 5.1 homework definitions seems to be a piece that tends to get people a little confused. But in fact, the idea is very, very simple as soon as you understand what's going on with it. So let me see if I can, let's just take it a piece at a time. So if we go by our definitions, my first definition I want to talk about is what is an arc? Well, an arc is just a length of distance measured along the outer edge of a circle, right? So if I say arc or arc length, right? The arc, here's an arc, is a bit of a circle right here, right? Some measure the circle. So the arc length is going to be as if we took a tape measure out and measured along that arc length, right? So arc and arc length, those two are very, very easy to establish. What do we mean by them? All right. Why are they important to us here? Well, let me ask you another one of those pointed questions right here that I like to ask, which is where did the measure of degrees come from in the first place? Right? Let me back up a little bit. Where did this 360-degree business come from in the first place? It's really, really old. It goes back to this to in history all the way back to Babylonian times, to Egyptians. It is so old that we are so used to it in society that anytime somebody says a 360-degree turn, we know exactly what they mean. But then you start getting into this business about radians. What is a radian? Good Lord, that's some alien measure, right? Well, in fact, it's a lot more natural. After all, 360, who decided that 360th of a circle has to be 1 degree? Right? There's no real reason. It's sort of arbitrary. Why didn't they say 100? Why didn't they say 10? So we would want to say, well, how do we get a more natural measure? And there's actually two ways that we do it. If you think about a circle, right? Let's go back to maybe something you might remember from a little bit of basic geometry. Here's a circle. Let me straighten this out here, get a nice circle going. Here's a circle. Do you remember the formula for circumference? Well, circumference is equal to pi times the diameter of the circle. Also, we could have said that the circumference is equal to 2 times pi times r, the radius of the circle. And of these two, this is the one that I want to focus on. Because imagine you have a circle with a radius of 1 unit, 1 foot, 1 inch, 1 centimeter, you name it, okay? So I have a circle with a radius of 1. Take a circle with a radius of 1. What is the circumference? Well, if the radius is equal to 1, then the circumference is equal to exactly 2 pi units, right? So if it were a 1 centimeter measure right here, the actual distance around this circle would be 2 pi, or approximately 6.28 centimeters. Still does nothing for you, I understand. Let's measure. In fact, 2 pi radians is the measure of 1 full rotation of angle in a circle, right? So instead of saying 360 degrees, right, the equivalent to 360 degrees is to say 2 pi radians. If you go half of that measure, you get pi radians. Pi radians is the equivalent of 180 degrees of rotation. Take half of that again. Half of 180 degrees is 90 degrees. So pi over 2 radians is the equivalent of saying 90 degrees of rotation. And consequently, the measure 3 pi over 2 radians is the equivalent of saying 270 degrees of rotation. Okay, so when we're looking at these measures in radians, those radians, well, okay, it seems like sort of arbitrary, right? Again, because, well, we're just using the formula for circumference to get that same business as we did before. But let me tell you why this is necessary. And it is actually necessary because all of the work that you do that deals with trigonometric functions when it comes to calculus will be done in radians. Always in radians, never in degrees. So how do we deal with that? Well, a radian is a very important measure, and here's a formal definition. It says 1 radian is the measure of a central angle theta that subtends an arc S equal in length to the radius of the circle. And you scratch your head and you go, huh? Well, let me give you a let me give you an illustration right here. Let me say that, all right, let's say I want to build my own radian at home. So what you do is this. You get a can, like, one of those coffee cans or something like that. Get a can and get a piece of spaghetti about the length of the radius. Right? So you can build your own radian at this home. So let's say I get a piece of spaghetti and it is the length of the radius. Right? And I just measure it out. I just snap it in half, and I get my radius length. Now I boil it up so it all gets nice and soft, and I take that and I just curl it around the outside of my circle right here. So the length of this radius is right there along the outside, right? So I just curl it around the outside. So what have I just got? Well, if I were to actually measure the angle in here, the measure of this angle is 1 radian. 1 radian right here. Here's the illustration right here, right? 1 radian starts at the origin and goes around the outer edge of the circle 1 radian's worth of distance, right? That is approximately 57.296 degrees. If you're measuring in terms of radians, that's what it means. Well, I mean, let's take a look at some other pieces, right? Because if I just took one piece, that would be enough, right? But let's say I took a second piece and I curled it around the outer edge, starting where the last one ended. Well, I'd be about here. Right? Then I took a third piece and I measured it from here on down. Right? I would be just shy of 3.14 radians. 3 and some change, right? So just shy. So here's 1 radian. Here's 2 radians. Here's 3 radians, right? 3.14 makes up my straight angle. 3.14 radians actually makes up my straight angle. Then I were to keep going again, right? So starting at 3, I come one more bit of rotation to 4. And then I go to 5 radians. So I'll come around my outer edge right here one more time. I'm at 5 radians. And then I come out one more time. And I'm going to pick a completely different color right here. How about shocking orange right here? So we come out here one last time, right? Here's 6 radians. 6.28 radians is one full circle. 6.28, right? 2 times pi is approximately equal to 6.28 radians. Right? So a radian is actually a very natural measure of the outer edge of a circle. In fact, it goes along with the arc right here. We just take our length of our radius, make it equal to the length of the arc, and just measure whatever angle we get in between those two, and that's what we call our radian. Very natural measure, right? So, more to come.